Yeah.
All right. Good evening, everyone. Um, we are from Women in Cloud Native, and this is Kubernetes 101. I'm your host, Sankita, your trainer slash mentor, Indupuri Bhavani. She has joined us from Bangalore, right, Indupuri?
So my first name is Bhavani. Sorry about that. So I'm from Hyderabad.
Okay, right now she's joined us from Hyderabad. Even I have joined you guys from Hyderabad. So, yep, glad to see you all having joined this session. This will be recorded since we want this to go on YouTube for your or even other people to refer to it later on if they want to. You can ask definitely, and please do pin your questions on the chat. We will have a QA at the end of the session, or maybe if we want to take a break in between. And we will make sure that all your queries are answered. So, yes, let's start with it. If anyone has any questions at this point of time, please feel free to pin them in the chat. Yeah.
So yeah. So one question from my side. So is this screen is everything is visible? Looks good for you, right?
Yep, guys, please confirm. From my end, Bhavani, I can see
Okay.
everything. Yes.
Awesome. Okay, then let's get started. So our today's agenda is so Kubernetes 101, which means so that all you need to know about Kubernetes fundamental concepts. So that's what I'll start off with. And okay, let's get started. So yeah, a couple of things about me. So I work as a senior DevOps engineer at Zscaler, and so I'm an organizer, one of the organizer women in CNCF. I have a lot of interest in CNCF technologies, and so I also speak at conferences, and I write blogs on Kubernetes containers and CNCF technologies and all those things. And also I recently completed my certified Kubernetes administrator certification as well. You can follow me on Twitter. So the handle in the Kuri Bhavani, and you can follow me on LinkedIn as well. So that's what all about me. So I mean, so before we start with the today's agenda, so I mean, like, Kubernetes is a vast technology. So here I wanted to cover up the fundamental concepts so that you're good to get started with the Kubernetes. And I hope you enjoy this session a lot. Feel free to ask questions if you have anything. So I'm good to answer all your questions. So let's get started. So today, so I'm going to cover about what is Kubernetes, and so why we need to use Kubernetes, Kubernetes architecture, and the few of the Kubernetes components, like pods, replica sets, and deployments. And I'll also talk about networking in Kubernetes and the services and a simple hands-on demo. So this is what I'll cover in this session today. So first, so before we get started with all the concepts, so first understand what is Kubernetes and why we need that, how it works, and all those concepts. So Kubernetes is founded in 2014, and it's an open source. So it's founded by Google. Later, then it gets converted as an open source under CNCF project. So this is the one of the biggest and most contributed project in CNCF landscape. And so if you see, today's organizations, so all the organizations, most of the organizations are using Kubernetes, and they're deploying their applications using Kubernetes. So why Kubernetes, right? So last time, so when I gave a session on Docker, I explained about containers, and probably I think like you have a bit of knowledge about it. But I'll in the coming slide I'll also explain the basic definition of a container. So like, I have a containers, so so that I can just deploy my applications. Then why Kubernetes? In the sense, so you can manage 3 to 4 containers, probably 10 containers, 20 containers. So what will you do? If you have to manage 1,000 plus containers, probably 1 lakh plus containers. So which means that your application is running that big and your applications are running on multiple containers, if what happens if one of the container gets failed, how you handle it, how you manage it, so how you scale your application, how you deploy your application. So everything y- is done by Kubernetes. So that's the basic definition. Like, so Kubernetes is an orchestration, so it orchestrates the containers to give all these features. So just give a basic idea of containers, right? So we started from this era where we started with the traditional deployment. So which means that we have so we used to deploy an application in your you're deploying an application in your laptop, so in one system. So where the hardware is being used by one application, and then later we move forward with the virtualization. So what is a virtualization is, in the sense, it shares that hardware layer, and on top of which we can have multiple virtual machines installed, so which has its own operating system. So for example, on one physical server you can install multiple virtual machines. This is far better than having one instance for one application. So now you can deploy multiple applications on top of one physical machine and having multiple virtual machine. This is later evolved as containers, where you are going to use the hardware along with the operating system. So on top of this layer, you have your application code only separated from that, and so where you deploy your application. So container is very lightweight because it has only the application code, so it used your kernel and operating system. So for example, in my machine, my physical machine, I can have multiple virtual machines. On each virtual machine I can have thousands of containers running. So which means that this is how in the corporate world that works is, so you have a virtual machines, and on top of which you have many containers running. That's how the applications are being deployed. So coming to next, so I mean like so now I'm going to explain about, so this is about so what I explained is until why containers, right? So you wanted to deploy an application on what I wanted to say is like the deploying applications through containers has become more easier. And so this is just separate out everything, so the container has only the application code base. So that's what I wanted to just recall those concepts. So now, so how Kubernetes work is, so we have virtual machines on top of which so we will be having this Kubernetes API server. So what it will do is, like, for example, so you wanted to deploy an application. So what user will do is here, so in Kubernetes we have an YAML files, so where you have all the configuration is listed. So with that YAML file, the user will just interact to this Kubernetes API server through a command line tool called kubectl. So what the user will do, so I'm gonna just run kubectl apply this deploy.yaml. So the deploy.yaml will have the information about, so I have my application, right, like my Docker image, and I want these many replicas, in the sense like I want this application to be deployed as thousands of instances. You can just mention that, and you can just mention what is your container image that you want to deploy application as pod. So the kubectl is the command line tool which you use to interact with the Kubernetes API server. So the Kubernetes API server will interact with the other components of the Kubernetes cluster. So don't worry if you don't understand yet. So I'm going to explain this in the coming slides. Now, so the Kubernetes API server, with the help of scheduler, schedule your application uh, on the virtual machines that lie behind. So being an end user, I don't need to understand where my application is going. I just tell just kubectl apply. and my configuration file. It just handles, deploying your application on the nodes, and if you wanted to scale your application, it just like, again, you just apply the changes, and it will just take care of everything here. So for example, what I'm trying to do is I wanted to deploy three three replicas of my application. So I just used kubectl apply. So what it did, it deployed three pods. So here pod is a simple unit that can be deployed in a Kubernetes cluster. It is a small unit. Okay, so what I would say is, like, in Docker you have a container, right? So pod, in the sense, within the pod, so you have containers running. So in Kubernetes, you deploy your application as pod. Inside the pod, your container is runs. That's where the pod comes into picture. So now, until now, you just applied your deployment. So now, on top of Kubernetes API server, your pods gets deployed. Now, so how will you load balance that, or how will you expose that application? That's where the service comes into picture. So service is a kind of a load balancer that drills down traffic into your application. For example, I want to access my application. When you run facebook.com, so right, so it has to go through the service, and it service will automatically load balance your request so that it will go to a particular node of your so inside a node, you'll get to a specific pod and you'll get the response back. So service is kind of a load balancer. And so I already mentioned about deployment. So that's what here I wanted to explain. So here you can see this part. So cloud load balancer, what it means is, so until service you set it up, but from externally you want to access your application. So that's where, for example, the Kubernetes can be hosted in your local, or there are cloud providers which provides the Kubernetes service for you. So like for AWS you have EKS, for Azure you have AKS, and multiple cloud platforms provide that Kubernetes service for you. So based on the if you define a service type as a load balancer, it will create a load balancer, kind of elastic load balancer for you, so that it assigns an IP address. Through that IP address or the DNS name, just like what I said, when you click on facebook.com, what happens is, so here is the user, so where you want to deploy this image, and you click on so you just deployed it through here, and you set it up the service, and service type as load balancer. Now everything got set it up. So now what you will do from here, you'll just it's an IP address for, let's just think as a, you're just hitting a facebook.com. So it goes to this load balancer, and it load balanced the service, and then based on the load balancer makes a decision, like which pod that it has to go, and then you can access that application. That's how the flow comes from here. From service, you'll just enter to the pod, and you can see when you deploy, these pods will get deployed into virtual machines. So virtual machines in the Kubernetes term, um, okay, so let me just answer the question in a minute. So when the the virtual machine in Kubernetes is considered to be a worker node. I mean, like, probably I'll explain the next architecture image where you get to understand. So consider this way: you have a virtual machine on which it is considered as a worker node in Kubernetes, on which your application instance is running, which is called pod. So the service will what the service will do is, it will enable the traffic down to your application to the pods. That's what I am trying to say. Uh, so one question I have: when you mean three replicas, you mean of replica copies of your app? Yes. Yes. So what I mean three replicas is your three copies of your application is going to be deployed on three containers. I mean three pods. That's what I think I have answered your question. So yeah.
So, Bhavani, someone is asking if we could go through the demo as well. Are we planning to upload it somewhere, like separately, or
So
so?
I'll be. I mean it is recorded. So where demo is also be there.
Okay, so people, just for a confirmation, we will be uploading this entire thing on YouTube. So, you, in case you're missing out anywhere in between, you can go to the YouTube channel later on, and we'll pin the thing down in your Gmail so you can get through it. Yeah.
So I hope you understand my point. I mean, like Kubernetes is kind of a complex thing, but let's go to other slides so you will understand it better. So the next thing I would like to the next thing I would like to tell is like why Kubernetes. So why we need this container orchestration. So one is like you can manage containers at scale. For example, you have thousands of containers and one of your container is crashed. So what Kubernetes can do is it will auto create a new container on the in place of that, and so that your application it just makes sure that whatever the replicas that you mentioned through your code, it just makes sure those many pods are always up and running in the Kubernetes cluster. And it, as I said, like it monitors the containers, and the next point is it just runs pods on multiple nodes, right? And it just schedules. So what I mean scheduling is, for example, so you have multiple nodes, you can provide a scheduling decisions. So for example, I want this pod to be deployed in this specific node, or else this node don't have to be deployed on of this pod. You can specify a scheduling decision, so it gets scheduled on a whatever the condition that you mention in your YAML file. And auto scaling in the sense, for example, your application is having heavy traffic in the morning, so lots of people access your application in the morning, and during the night time you don't have much users. But so what Kubernetes can do is with horizontal auto scaling. So it will increase the nodes and your pod count based on the user access, based on the heavy traffic. And if it's less traffic, it can reduce the number of nodes and pods. And the last point is a self healing. It will, if some container fails or crashes, it will recreate it automatically. So there is no need for you to manage, and you need to monitor every pod that your application deployed and all those things. You don't have to do that. So that's where Kubernetes comes into picture. So any questions so far? Okay. So yeah. So I'll get to the next slide. So where I'll be explaining about the Kubernetes architecture. So here, if you observe my explanation so far, I just mentioned we have worker nodes, and we have a control plane. So that consider this two ways. So in a Kubernetes cluster, we have two types of nodes. One is the master node, and other is the worker node. So worker node is where your pods gets deployed, and the master node is for managing the entire Kubernetes cluster. So when user talks to your cluster, so it talks through the Kube API server. So which means you can consider a Kube API server as a UI of your Kubernetes cluster. So you can just interact with it through kubectl command. So what Kube API server does is, so it interacts with all other components in control plane node as well as the master worker nodes. So here, if you see, there is an etcd and control manager, scheduler, and Kube API server. These are the four major components in control plane node that we also call as master node. So what is etcd is, it's a key value store. So where you get, for example, when you do when you want to get the nodes information, pods information, replication, so whatever the information that you need in your Kubernetes cluster, so that is being stored in etcd. And the controller manager, which controls I mean, like, so we have multiple controller managers, like replication controllers, node controller manager. So replication controller makes sure that the number of replicas that you mentioned in your deployment file, or some other type of your state, so it just makes sure those many replicas always be there in your Kubernetes cluster. So that makes sure that it has like high availability. And the next thing is scheduler makes sure that it decides like which pod to be deployed on which node. So the scheduling decisions has been done by the scheduler. So if we go to the worker nodes, we have where I already said, like application runs, which means pod runs. So we have a container runtime, container D, we have multiple container runtimes. And the kubelet means the agent that runs on all the nodes. It just makes sure that the containers are up and running all the times. So this is all the information about so what are the different components, control plane, and also the worker nodes and their components. And we have other thing which I forgot to tell you is a queue proxy, so which is a networking component which makes sure that the networking happens in within the nodes actually. So that's about the architecture. So let me just go to uh, components of Kubernetes. So I mentioned these things, right? So pod deployment and services. So let's get know about these details. So pods are the, as I said, like pods are the smallest deployment units. If you see this is the Kubernetes cluster. Inside we have multiple nodes. So where you see the pod is running. For example, you want to scale your application, which means that you have to create a multiple pods. It's not that to scale your application within the same pod I create multiple containers. No. So if you want to scale, you have to create more pods. So pod can be considered as a one instance of your application. And the second point that I wanted to tell you is, see, so this, like, you can have a two containers within a pod, but those are in the case like as act as a helper container, which means, for example, for your application you want to find out the logs, all the metrics of it. So then you have a helper container where you can just read those logs. These kind of for these kind of situations, the helper container will be useful. But to scale your application, you should create another pod. It's not that you create a so for example, you want 100 instance of pod. It's not like you have to create 100 containers within a pod. It's like you have to create 100 pods. Okay. So as I said, like YAML files, right? So this is how it looks. So it's the first main points, like API version and the kind. Here I'm just showing you the pod, and metadata is like the name, labels. So this namespace, these kind of information. The major configuration is under spec section, where you can see. So I have listed about the name of the container and the image. See, here the image means the Docker image, so it will pull from the Docker hub. And so it will create a container, I mean, it will create a pod if you just apply this definition. So I'll show you when I go to the demo. This is how the pod YAML looks like. Okay. So kind is a type of a Kubernetes resource that you're creating. So there are multiple resources. As I said, like you have a pod, you have a deployment, you have a replica set, you have daemon set, service, ingress, network policy. There's so many. So these are all examples of resources. So the kind defines that. So what type of the resource it is. So here, so I'm showing the pod definition. So it is saying the kind as pod. I hope I answered your question, Tulsi. So that's about it. So let me start with, so this is about pods. what is replica sets, right? So I've been mentioning from the starting. For example, if you say you want your application to be 500, I mean like four replicas. So where you mention about in the deployment, you mentioned that I want four replicas so that it will create a replica set. So what is a replica set means? So we have a replication controller. So if you see here in this diagram, so which manages based on your specification. So it makes sure that those number of replicas of your application are created. So it can spread out across your nodes based on your user traffic. For example, if 1,000 users are accessing your application, so 1,000 replicas you wanted to create, so those 1,000 replicas will spread of replicas of your application will spread across 1,000 node. Not 1,000 nodes, sorry. So those 1,000 replicas of your pods will spread across the nodes based on the node capacity. Okay, so that's where the replica sets are mainly for, just to make sure that we have those many instances of your application are up and running. It just makes sure it, and if one of the instance is down, it just makes sure to create a new one actually. Okay, so I will show you, how a replica set YAML look like. So here, so if you see that again, like API version and the kind is, as I said, like it's replica set, just the metadata. So the main thing is inside a spec. Where you see this, it is a replicas it is showing. There are like three replicas. So which means that, so you want to deploy this application as a three parts. And I'll go to the selector part next. So coming to the template, so inside the template, this is all the pod definition. So as I just now show you the pod definition, right? So here, so same like from here to here it's what you're defining here inside a template. So you're telling the replica set that I want this pod configuration to be created as a three instances, three replicas. And why this is selector in the sense, so labeling is important in Kubernetes, that so that your application can be found through that label. So it is so why, so because we are passing the pod template, pod definition in the template itself, why we are again using a selector to make sure that this replica set controls these pods with that specific labels. So because even though you have those pods, the old pods with the same label, and you created a new replica set, it makes sure to control and monitor the existing newly created pods along with the old pods which has the same label. That's where like selector is very important. It should know, right? So which pods that it needs to monitor, so that it will get to know through the selector and match labels field. So this is the uh, you know the kind of replica set, and you could see the similar configuration for a deployment set. I mean, a couple of fields you will get to change, but it looks similar for replica set and other applications as well. And the next uh, part is like, so let's get so you get to understand a pod. It's a small unit, and where it's an instance of your application, and the replica set based on how many replicas that you mentioned, it just monitors and makes sure those many pods and your application's instances are available in cluster. So now so we have a replica set, we're deploying application, but why we need a deployment? Deployment makes sure that, so so the rollout updates, rolling out your application, so deploying your application can be done without having a downtime. So it creates a rollout of your replica set. So when you create a deployment, in the background it will create a replica set. So and also what it will do is, it just makes sure that so your application is deployed, so one after other. I'll show the deployment strategy next slide so that I can explain you well. So the next thing is, once you deploy your application, for example, if you see a failure, so something happened and your new version is not working fine, you can roll back to your previous working deployment version. And if you want to scale your deployment with replica set, it's difficult for you, but if you want to scale your deployment, so you can just scale the deployment with how many replicas that you need, and you can check your rollout status. And for example, you have multiple changes to be done, you can pause your deployment and get all the changes to be rolled out at once, and you can check the status deployment. So there are all of these are examples of why deployments are being used. So if you see here, so there is a so when you create a deployment, it underneath create a replica set based on the number of replicas that you mentioned, but it gives additional features of what deployment can do, which is rolling out strategy, and you can get the history of your rollouts, and you can pause uh, you know um, your rollout, and you can undo if something goes wrong. So all of these features comes with the deployment. And there are two types of deployment strategies. One is recreate and rolling update. So when you use a recreate deployment strategy, what happens is, for example, you have an nginx application with 1.7.0. Now you want to upgrade your application. So when you create a recreate, in the sense all your pod replicas will be down at once, and it creates a new ones after making all the pods down. What happens, it will make your application down for sure. So consider if the application is being used by so many users, so and one you see sometime back a Facebook is down for a couple of minutes. So that shouldn't be done, because we just need to make sure that the service reliability and trust from the customers. So recreate is not the best option, and so it's not going to be used. It should be rolling update. So what rolling update in the sense is, so when you wanted to and upgrade your application, so what it will do, it will make one pod down and create a new pod and attach to your cluster. And again, it will make one pod down and it will create a new one and make the other pod down. So it's one by one. So your application is available all the time, even though you do maintenance activities, upgrade and everything. So you just make sure it is your application is highly available all the times. And you can see the deployment. So as I said, like, it looks similar to replica set, but there are like couple of options. So here the kind is deployment, and we're seeing the replicas, 3 replicas. So it underneath create a replica set, and you want to definitely monitor these labels, of the pods. So you just mentioned this match labels, and you can see the strategy type. So where you're saying the rolling update, and so the template is where you're having the container definition. So that's how you just create a deployment. It manages through a replica set, and you can do everything from there. Yes, rolling update is better than recreation. Okay, so the time duration is 1 hour, but I'm just trying to complete it within the time. As I said, like, it's really huge to understand Kubernetes, but I'm trying to give you the basic idea of what Kubernetes can do. And the next thing, so far we just understood what is Kubernetes and different Kubernetes components. Other than the deployment pods and these things, there are multiple other Kubernetes components as well. Like, you can have a daemon set. So what daemon set means is, I don't explain in detail because this time frame wouldn't fit that. But what is a daemon set means, it just makes sure, so if you create a daemon set of your application, it always makes sure that the application is created across all the nodes. So it makes sure this is useful in case, for example, you want to get the node metrics. So where you want to run your application across all the nodes. Okay. The next thing is stateful set. So what stateful set is, like, for example, your application. So when you're using your application and you have some data in it and you want to preserve that data. So it's not that when your application is closed and you open back and it comes with a fresh state, right? So you want that statefulness to be added. That's where the stateful sets are there. Okay. So that's the couple of points I would like to discuss. And next is like, let's go to basic networking uh, things that I would like to discuss. Okay. So, networking is a central part, and there are a couple of problems that we have. So, container to container communication, which means that within a pod, you can have, as I said, like you can have helper containers. So, on container communication happens through local host, right? You can just communicate through local host. The second is the pod to pod communication. So that I'll going to explain the next slides. So we just need to make sure in cluster each pod can be able to communicate with the other pods, and the pod to service and external to service communication. So these things I'll get to explain in the coming slides as well. So coming to how network happens is, if you see here, so each node will get an IP address, and each pod, so unlike Docker where each container will get an IP address, here each pod will get an IP address. And Kubernetes in the background will create a internal private network, so from where the pods of the nodes will get the IP address from. So for example, so if you have another node, and so when the Kubernetes creates an internal private network, see if these two addresses are same, so the pod addresses will end up becoming same. It should not be the case. So we should make sure that, so each pod, so how many, so if you have 100 nodes, and within each node you have tens of, probably 20s, hundreds of pods, you just need to make sure each pod is assigned a unique IP address, so which Kubernetes don't automatically handles that. That's where you just need to make sure to use some networking plugins, kind of Cilium, and I mean like ViewNet. So there are a couple of plugins, add-ons that you can install in your cluster, so that it will handle to make sure that each pod has unique IP address, so that pods can communicate with their IP address directly. That's where pod to pod communication happens. And the next, so that's what I'm trying to see. So using the network plugin, so here so this is a Kaneko network plugin. So each pod is assigned to different IPs, and even this network here is having a different IP addresses, so that routing and everything can be managed through that plugin. Okay, so that's about networking. So we just need to make sure that through networking plugins, that networking solution is embedded into your cluster. And coming to next, so as I said, like services act as a what it will act as to route traffic from your service to your application inside, which pod that your application to move to. Inside, lot of you have lot of instances through lot of pods, right? When user requests, one user hits the service, and it will go to one pod. If another user hits the service, it will go to another pod. So which the way how the traffic flows is defined is done through a service actually. So, and if you see like the pod, you can't believe in the pod networking, because what happens is, even though each pod is assigned a unique IP address, so but some cases you want to scale your application, so the pods will get increased, more IP addresses that will come, and one of the pod may crash, and it will create a new pod, so it will have a new IP address, so you can't trust the IP address of a pod. So that's where the service makes sure that if you attach a group of your pods of similar kind, for example, all the backend pods can be exposed via a backend service, so the user hits the service, so they can be able to access the background traffic, the service will handle it. So that's where the service comes into picture. So you can recognize your application, you can access your application through a service, instead of directly accessing your pod IP, which can't be trusted. Okay, so 1 minute. Okay, so now I just try to explain the service definition. So now let me just go to the types of services. So we have three types of services. One is a node port, cluster IP, load balancer. So I'll just go to each of it. So first, cluster IP in the sense, so the service also makes sure that it's not that your application can be accessed within the cluster. So end user, wants to access to it. For example, I want to access the application from my laptop within the cluster, right? So I don't want to just SSH to the node and access my application. No, I want to directly access the application from my machine. So that external access is being done through services. So that's where, like, if so in case of cluster IP services, what it means is it enables that traffic flow and communication within the cluster. It's not that you can using cluster IP you can access it from outside the cluster. So cluster IP is an internal networking service system. So where you see all the front end pods are exposed via this service, so that you can directly hit this back end service. So it just handles which pod you have to go. Okay, so that's about the cluster IP service. And so the node port service, what it means is, so your application is opened at a node level to a specific port. So for example, if you create a node, so this is the YAML file. If you create a node port type of service, and it opens up this one of the node port, which is, there is a range like from 3000 to 302767. So these, within the range, node port is gets allocated, and you can access this application through node port. For example, you can just run http IP address of your your node, and then port 3008, so that you can be able to access your application. So what it will do is, like, it just maps this node port to the service port, and then it just maps to the target port. So target port, in the sense, it's a actual port where the container is running, and it just mapped to these two. So now you can access your application from my machine using a node port service. So I can just use the IP address of my node, and pass this a node port, so I can access from my machine. This is for external access, right? And the third part is, so this is what I meant to say. So for example, so your application is spread across multiple nodes, and you want to access your application, so you enabled a node port service. So now I can access the same application using the IP address of each pod, each node, and using the port which I mentioned. So it will open the port across all the nodes where your application is spread. So you can access your application through multiple IP address and of the node actually. So that's what a node port means. Now, typically in organizations, so when your application is running in production, so we usually use a load balancer type service. So what is a load balancer in the sense is, it only works if your Kubernetes application is hosted in one of the cloud provider, like, as I said, like AWS, EKS, or AKS. So these kind of platforms. So how it will do is, when you specify a load balancer service, then Kubernetes creates an elastic. I'm just explaining in terms of AWS. It creates an external load balancer, and so from that the traffic flows. So if you see in this diagram, I'm just hitting the www.example.com. So it just go through the load balancer, which gets created inside your service provider. And this load balancer have its own IP address, and IP address assigned, and the DNS assigned, like, so that's what we are hitting it to www.example.com. And now it will hit the service in the background, and where service will handle the traffic flow. So I mean, for the request, which endpoint it should go to. So that's how the load balancer service is. So if you see this, just so your application port is 80, and you're targeting to that port, and your just traffic flows from your DNS name into the load balancer, and then it will go into service, and then it will go into node, and then port. So that's how the flow happens. Okay, so far I think, okay, I still have 10 minutes time. So I mean, like, I try to explain it fast, so I will answer all your questions 1 minute. So the next thing is demo only. So okay, Why there is a need for pods to communicate or exchange messages or collaborate. Multiple containers, that means application and its independent components as well. Why there is a need for pods to communicate, right? So why there is a need is, for example, you want um, like, I'll explain this. So you have a multiple pods, so you need to get some in something, so okay, so I'm just trying to figure out the exact thing that I have to mention. These pods can have multiple containers, that means application and its independent components then run in another container in a pod. Yeah, but there will be definitely an intercommunication between the pod should happen. So probably I'm not getting the exact way to answer it. I'll just reach out back to you, Tulsi, on this one. Okay. So yeah, Sangeeta, you have anything?
I was just asking if people still have doubts or questions, just make sure you pin them in the chat. We will try as much as we can to answer them within the given time frame. If not, we'll contact you via mail. Yeah.
Yeah. So it's not that it's always a web application, right? So you can host everything in Kubernetes. For example, so being a DevOps engineer, I have to uh, okay, to have pods. Yeah. So yes, so there are like multiple questions. I'll answer by one, I think so. So Chitra is asking, apart from web app, where else people use Kubernetes? It's not only a web application. So for example, I use a like Jenkins, right? So you can deploy that application over there where you can manage. So all the applications that you have, you can just use it, deploy that in Kubernetes. So it's kind of a microservices based applications that you deploy, because you need what microservices, all of you know, definitely, you need to have a multiple components, right? So for login you need one component, for backend you need one component, for database you need one component. So for all of these things, so you can just couple it and you deploy your application in Kubernetes so that it can handle it well. And there is another question. Is there any equivalent tool? Yes, there is equivalent tools. Docker Swarm, you can use, and I think OpenShift has its own solution. You can use that. But Kubernetes is a really widely spread open source, and it has really good features. That's what people are tend to use Kubernetes. And okay. Uh, how to set up ingress on Kubernetes? Okay, I think Lakshmi, I'll probably reach out to you later, because I mean, so here I'm not trying to give all the information, because we are shorting of time. But I can say, just quick note on ingress. What ingress do is, you can load balance your application based on your rules. For example, if you want to so in www.example.com, you want to have a this kind, like, so food items. So if you specify www.example.com/food, so based on that path, you can define rules in ingress. So it should define for this specific path where which pods you should go to. So that's where you can define the rules of your traffic flow through ingress. Okay. uh, Okay, so yeah, so there is a one question asking for real world example. I will tell you this. So probably all of you, watches the cricket matches, right? So when you watch a India Pakistan match, you get to see, in Hotstar, more than 1.2 crores of people watching it, are like, it's even more. So how they are handling it? So how they are making sure that there is no network glitch, and there is no, uh, uh, connection issues, how they're doing it. At the end, what it happens is, So because you're watching all those 1.2 crore sessions at the same times, in the sense in the background those 1.2 containers are being created and being managed by the Kubernetes system, and making sure that high availability is there, with all the Kubernetes features that it has. I hope this question answered you. And so there are like so many, for everything we are nowadays using, container orchestration, deploying in containers. Each and every application is using it to make sure it's a high availability. So because of its widespread of features and everything that it provides. Okay, so this is about this one. Uh, ETL things. I'm not sure on what ETL means. Sorry about that. Uh, okay, so yeah, not exactly. So what is ETL means, Chitra? Okay. Apart from that, yeah, I hope I answered all your questions.
I think ETL, she's talking about extract, transform, and load. Is that the one you are asking about, Chitra?
Yeah, I think that's the thing, but I'm not completely sure about what it means. Probably I'll just try to figure out and reach you back, Chitra. Yeah, yeah, that's about it. Okay. So the next thing, so if everyone is good, I'll just show you a quick demo. So we have 4 minutes left. Do one thing. I'll just create a 1 second. So I'm just doing it on a virtual playground. So I have everything set it up. So it will be quick only. I'll be done in 5 to 10 minutes, not more than 5 minutes. Okay. So this is I just got my on-demand cluster using Killer Coda. So you can see. So this is my Kubernetes cluster. So I'm just interacting with kubectl get. So I just wanted to see how many nodes my cluster is having. So you can see there is a control plane node and node 01. So there are two nodes and which are in ready state, and it is showing the version, right? And I want to see how many pods are deployed. So, 1 second. It's taking much time. 1 second. I'm just sorry for that. So yeah, now kubectl get pods. So it is saying default namespace. So in Kubernetes, right? So you can deploy your application based on a namespace. For example, you're just giving your, uh, you know, your street name to identify you. So that's where you just create a namespace where, for example, all your resources of that specific application is listed. So to see the all applications, I can use get pods -a, so which lists all the applications within the each and every namespace. So you see this kube system namespace are the ones which related to the Kubernetes components. The kube system is being created. It's related to all the resources that Kubernetes owns, right? So you can see, so as I said, like there will be an etcd key value store, control manager, and you have a scheduler, and I said the kube proxy in each node. And so this codn is for DNS purposes, and this Calico is networking plugin that I mentioned, right? So you need to have a networking plugin installed to manage that networking in there. So this is all the things that I have in this cluster. So now, so I just walk you through this now. Just deploy an application. So I don't have any YAML files here, but what I will try, I'll quickly create. So it's easy. So with imperative commands, you can create your YAML files very easy. Let me just show you this. kubectl create deployment. So I'll say some Nexus. access deploy. So I want to create this deployment. I want to use an image, so the Docker image, Nexus image, and I want to create how many replicas I want. I want three replicas, for example. So I want to create this deployment. But so before that, I'm not just applying this directly. Usually, in production environment, you don't run the imperative commands. It should always through the YAML files and making sure your code gets checked in before you apply anything. So for demo purpose, I'm just showing you this, but I'm again creating a YAML file using this. I'm using a dry run option so that I can save this YAML file. So I'm just saving this YAML to deploy.yaml. So what it will do is it won't run in the background. It just dry runs it and saves that configuration in deploy.yaml. I'm just so showing this. You could see this is my deployment at YAML. So you just need to remember everything that you need to create. You can just create it on demand with using a dry run option. So so it just have a label assigned replicas as I mentioned, and it uses the same image that I mentioned here. And yeah, that so you can ignore this creation time. These are like added by default, but so these are the things that this deployment.yaml. Now what I'll do is I'll just apply this file. uh, Now I applied it. You could see so kubectl get deployments. You could see so there's a deployment, but you could see zero ready, so it's still creating those pods. Now just check it out. It should create kubectl get pods. Oh, did I use a wrong image name or something? Okay, there's some error. 1 second. So I'm just trying to figure out what's the issue using a debug command called describe. So it is saying it's failed to pull the image. Okay, let me just go to here, Docker Hub. I could see it's not the Nexus, I think. So okay. Nginx. Yeah, let me just update this thing. kubectl get deployments. I used the wrong image. Sorry about that. Uh, I'm just deleting this deployment. You can use a shortcut word for deployment. Delete deploy. So this I'm just mentioning this, just deleting. So you get pods. You don't see any pods now because it's actually, so when you delete your application, it's actually terminating that. So now I'll just edit my deployment.yaml. So I'll just update these things. I'll be done in 5 minutes. Yeah. Nginx. Just changing the name Nginx. Okay. Now I'll just apply this back. So we can use a alias for kubectl. It's not that you always type kubectl. You can use a shortcut. So using alias option, for example, I can set like alias k is equals to kubectl. You can set this out, so I can use k from now onwards, right? So I'm just apply -f deploy.yaml, and now kubectl get pods. You could see the containers are creating, right? So and so you can see kubectl get deployments. This application is up and ready. So you can see the pods now, 3 pods running. So which means 3 instances of your application is running. So now you have your application running, but you need to expose it, to view, to be able to access this application. So let me create a service, kubectl. So we can use this expose deploy. So, and deployment name I use, I think so, nginx deploy hyphen hyphen. I'm just giving a port of the nginx usually automatically comes with port 80, so I'm just using it. So it gets deployed, which means that a new service we are creating. So here I don't specify a service type, whether it's a node, port, cluster IP, or load balancer. So which means that by default it will create a cluster IP, so it enables within the cluster communication. So that's about it. So if I just run kubectl get service, you could see this nginx deploy with the IP, service IP. You can consider it as. So now how you can access this nginx application? Just do curl http:// with this IP address and with port 80. Done, right? So you can be able to access the application, right? Okay. So I think that's about it. So here, what I tried to show you in the demo is deploying your application, and if you want to scale your application, for example, so now I just exposed it to a service so that I can be able to access my application. You can see now I can just curl it, and so you see this is the sorry about that. So this is the IP that is created with the service. Probably I can just describe the service. Get service ctl describe. SVC is a short form for service. Okay, so you could see what it actually shows you. So this is the service, and which gets attached to this deployment with this label. So as I said, labels are very important to integrate with the things, right? So, and it has this IP, and you see these endpoints, right? So as I said, it just makes sure that since your applications like having a three pods, it's running and three pods has having a different IP addresses. This is like pod IP address. In that specific pod, you can access that port. Let me just show you the get pods hyphen o wide. See, this is the pod IP. So the endpoint specifies like from this IP of the service, it will just flow down the traffic, to the pods. So that's what the endpoints, right? So this from this service IP, you can just get to any of these endpoints. That's what it's trying to give that information to you. So these IPs are your pod IPs. That's about it. How service actually comes from a service to a specific pod. Now that's about it. I wanted to yeah. So I have a deployment, right? I just told you you can scale your deployments like any number of instances. Like, so I can use kubectl scale deployment. So I just wanted to I just want I got a more traffic to my application now. I wanted to scale up my application to 5 replicas. What I'll do, uh, I'll just run this. So what it will do now, just check. There are like 5, that your instant got scaled up. So very easily, and you get to see 5 replicas gets created. And if you just see get pods, 5 instances of applications are running. So, if you wanted to do a version upgrade, so you just need to update your deployment file and just apply it. Just make sure that it without even making your application down, without even end user knowing it just roll out those changes one after one. So that's how Kubernetes comes into picture. It's all about orchestrate the containers with from starting, right? Sorry about that. I got a phone call. Okay. So what I mean to sell is like you have a containers. What container orchestration does is it helps you with handling more containers, right? So to scale your containers, to self heal your containers, to make sure that the desired state is always there. So based on your desired state, for example, you want 10 replicas to be running, it should make sure that 10 replicas always runs. So if something goes bad, it will recreate it. So everything happens through Kubernetes. You can monitor your containers. It will self, manage everything, so that you don't have to write lot of custom scripts to enable networking between containers, to enable storage between containers, to self heal the containers and all this stuff. That's what containers orchestration does, and that's what Kubernetes can do. I think, yeah, that's all about it. I probably am little bit faster because of the time constraint, but Kubernetes is really, really vast. Believe me, like I took me 2 months to prepare for certified Kubernetes administrator. So now what I'll suggest you is like you can use Kubernetes.io documentation, or Code Cloud is a great resource where you can get complete trained and you can be a CKA as well. So yeah, it's really vast to understand, right?
Thank you, Bhavani. Thank you so much for hosting the session and being able to clear out so many doubts. I hope everyone has got their replies to most of their questions. We have got some suggestions as well for the demo, and if you have gotten stuck anywhere in between, you can refer to our YouTube channel video once again.
Yeah.
Anyone having any questions at this point of time, you can pin in the chat, although I don't think we have much time to answer them, but quick in 10
So
seconds.
yeah, one thing I would like to, there's a YouTube channel name. It will be definitely Women in Cloud Native, and I mean like if you feel like some concepts you need more understanding, you can feel free to reach out to me as well. So I just went a little faster. I mean like if you have to learn Kubernetes and if I have to explain all the concept, it definitely takes more than 5 to 6 hours for you know it's really that huge and complex as well. Yeah.
So our channel's name is Women in Cloud Native itself. Maybe I'll just try to ping this.
Yeah, I should say thanks to all of you for joining and keep supporting us. We try to help, and so our intention of Women in Cloud Native is like whenever I attend a Cloud Native meetups or anywhere, I see very less participation from women, and so I mean like we should make them inspired, and I know like what woman has to deal with every day, being a woman and being a mother. I have to really go through a lot of things to make time for everything. But if we think we can do it, we can do it for sure. And just be passionate and do your best. And I mean, like, we can handle multiple things. It's not like that. Yeah, that's what I wanted to tell.
There is a last question from you, from Amit. He's asking if we are going to capture the security aspects also in the upcoming sessions.
Yeah, so actually, so we will definitely do more in the upcoming sessions. Will definitely consider this, but we'll also encourage people who wanted to talk, reach out to us, and so probably you'll be the next speaker giving a session, so that everyone will learn from you as well. We encourage you to share about women in cloud native, encourage your women contacts, and so all of you, please join next time as well to learn the cloud native technologies. And yeah, thank you so much for the support you all of us gave us.
Thank you everyone. Thank you Bhavani once again for making all the time from your busy schedule to help people learn something more. Thank you everyone, and yeah, definitely do ping us on our individual profiles, or even we have Women Cloud Native on Twitter. We are there on LinkedIn. We are there on Discord. Just feel free to ping any one of us, or even Nancy Chauhan. We three are the community builders for this. So definitely we would love to entertain your doubts as well as have you the next time once again. Thank you
Yeah,
everyone.
and if you have interest, you can join hands with us and be the community builder and work with us as well. Yeah. Thank you so much. I think I'm stopping my recording, Sankita.
Sure. That was great.